Hello guys, welcome back to another AIME problem solution video. Today we'll be discussing yet another problem, and as always, let's start off by reading the question. So, let x, y, and z be real numbers satisfying the system of equations xy plus 4z equals 60, yz plus 4x equals 60, zx plus 4y equals 60. Let s be the set of possible values of x. Find the sum of the squares of the elements of s. So, let's label these three equations as the first equation, second equation, and the third equation. So 1, 2, and 3. So we need to solve for all the values of x. So let's first do the first equation minus the second equation. Now when we do this, we will see that xy plus 4z minus yz minus 4x should equal to 0, as 60 minus 60 is 0. Then we can factor this. So, for z minus x minus y z minus x is equal to 0. Eventually we get z minus x 4 minus y. So, now that we have this, we can see that either x is equal to z or y is equal to 4. So let's first start off with our first case, which is that y is equal to 4. So right here, y equals to 4. So from this, we can plug in y equals to 4 into the first equation right here. So xy plus 4z equals 60. We'll plug it into there, and we will get that 4x plus 4z is going to be equal to 60. Then we get that x plus z is equal to 15. Now let's plug y equals 4 into the third equation. So we will get that zx is equal to 4 times 4, which is 16. So we move the 16 from this side to the other side, and we get 44. So now we have two equations. X plus z equals 15, zx equals 44. Now since they are all supposed to be integers, we can easily get that x is equal to 4 and x is equal to 11. So x is equal to 4, z is equal to 11, or vice versa. Now let's talk about our second case. So x is equal to z. Now, without loss of generality, we want to find x, so we will turn all the z's into x's. So we will plug this into the second equation. So we get that. So this is the second equation, by the way. We will get that xy plus 4x is equal to 60. And then we'll plug this into the third equation. So we also get that x squared plus 4y is also equal to 60. Now again, we will be subtracting the second one from the first one. So we will get that x squared plus 4y minus xy minus 4x is equal to 0. And like this, we will also be factoring it, and we'll eventually get that x minus 4 minus y, x minus 4 is equal to 0, and then x minus 4, x minus y. Now, since x equals 4 is already the answer that we have, we won't be discussing this case, and instead we'll be discussing that x is equal to y. So now from this, we can do our third case. So from this, we can push out another case, which is that x is equal to z is equal to y. So in other words, they are all the same. We will plug this into the first equation. So the first equation is this one. We will get that, or we can plug it into this one if you really want to. We get that x squared plus 4x is equal to 60. We move the 60 to this side. So x squared plus 4x minus 60 equals 0. We factor this, so we get that x plus 10 times x minus 6. So from this, we get that x is equal to negative 10, 6, and from above here, 4 and 11. So we need to find the sum of the squares of the elements of s, and this is s. So negative 10, 6, 4, and 11. So our answer should be equal to 10 squared plus 6 squared plus 4 squared plus 11 squared, which is also equal to 100 plus 36 plus 16 plus 121, which is equal to 273. So the answer to this question should be 273. Thank you guys for listening. If you have any other way to solve this problem, please let me know below in the comments. Thank you guys for listening. Bye.